Hey, this is Scott Allen Miller here on Sam IT on YouTube. Today we are continuing our series on RAID. Oh, and inadvertently, we are not being sponsored today by Hewlett-Packard, but they do have a cup that made it in. So they get a freebie on this one. Good job, HP. That's what you get for giving me my favorite coffee mugs. When we're talking about RAID, one of the things that's important to remember in how we think about it is that, and we haven't explained this yet, is that, so the name, redundant array of inexpensive disks. That means we take many disks and we turn them into a single array. Now, what do we mean by that? So RAID is a storage virtualization technology. And what that means is we're abstracting the storage. RAID takes a bunch of underlying storage components, which are disks or disk appearances, which you can see on SMB IT Journal. I have what I think is a good article about the concept of disk or drive appearances. And we have a MangoCon video that explains that as well. MangoCon 2016 storage, that's my talk. So check that out, and I'll try to link that below if I'm diligent on that. And what we get is these things that are or appear to be drives, and RAID merges them together into a single drive. So many drives in, one drive out. Technically, there's things you can do with RAID controllers to make it present multiple drives. We're going to talk about that in a different video. That's not actually the RAID system. It happens to be handled in some cases by the RAID controller, but it's not RAID itself. RAID is multiple in, one out. So if we have, let's just take an example. We're going to take 6 disks and put them into a RAID array. We don't care if that's RAID 0, 10, 4, whatever. We're going to get a single resulting disk that we can then present to the next layer in our storage stack, whether that's a logical volume manager or a partitioning system or a file system, right? Doesn't matter. It's going to appear as a single disk when we present it on to the next layer. This is a really important concept when working with RAID. It sounds simple, and it is, but a lot of people are going to forget this and forget what this means and how it will affect other things. And it's important for just understanding how we're going to talk about it. So it's not a complex concept, but it has complex ramifications in some cases, especially when we start getting into failure modes and understanding what it means when an array fails. So multiple disks, 4, 8, 100, merged into a single array and presented as a single disk to the rest of the system. Should that array fail, and we'll talk about failure modes because each RAID level has a different type of failure, a different concept of what failing means, but once an array fails, well, let's back up. A degraded array does not mean that the array has failed. An array continues to present, when healthy, it presents a single disk to the operating system. The operating system can see that disk and use it as if it's any other disk. It has no idea it's a RAID array. That's important. That's what abstraction means here. It is fully encapsulated, fully abstracted, and that's why we call it storage virtualization. We actually often use virtualization to mean encapsulation and abstraction as a concept. So the operating system simply sees a disk, a normal, everyday, healthy disk. If a RAID array becomes degraded, meaning some underlying component of the RAID array has failed, but the RAID array itself has not, then the operating system or hypervisor or whatever will continue to see the RAID array as a single, healthy disk. It has no idea that something has failed. Of course, your RAID system might be able to send a signal up and say, hey, something's degraded, you need to be aware of this. That's separate. That's a signaling concern. But the RAID array itself at the RAID level has no visibility up to higher levels that something is wrong, nor should it. Those systems simply see a healthy disk. The fact that underlying components may have failed is totally the purview of the RAID system, and RAID needs to handle it. And the RAID system can handle it. So we have this degraded state where something's wrong and it may get repaired and become healthy again. Again, the operating system has no idea. Everything just works. It's magic to the operating system. It just works. Now, if things degrade and more fails, if we actually get to a point where the array fails, this to the operating system is the same as a disk failure. All is lost. It simply doesn't work anymore. The disk stops functioning. So this is what would be catastrophic, right? We lose all the data on the RAID array. All of it. That's it. can you go to recovery services like disk savers or something? Yes, they're going to physically tear things apart. They're going to leave the realm of IT and go into hardcore, under the hood, pull the screws out bench work and try to actually read the platters and reconstruct the RAID enough to save your data. That stuff does exist. Don't count on it. That's not how RAID is meant to be used. RAID is meant for you to gauge the capacity and reliability and performance that you need appropriately, know what your risks are, and mitigate them through things like replications and backups and snapshots. That's how we are meant to recover from an array failure in a appropriate scenario. If you have to go to someone like Drive Savers, who's going to cost a lot and they're going to put in a lot of work to save your data, that means that not only has your array failed, but your storage planning has failed in a broader sense. That's a different issue. So when we're looking at RAID, though, this is very important. Degraded arrays may be unhealthy and may be in danger, but they still present as healthy disks to the final consumer, the operating system, hypervisor, whatever. And when they fail, they don't fail partially, they fail in total. The entire system goes all at once. There's no, oh, we lost some data, oh, it started to corrupt, no. It either works or it dies. And when it dies, all is lost. There's no coming back from a failed array. And sometimes you get kind of lucky that like you pull the power and you turn the power back on and you jiggle everything and it stops being a degraded array, or it stops being a failed array. Those things happen, but that's really the RAID system being tricked into things not having failed and reading a disk for a minute. That stuff exists, and it's not exactly what we mean. When we say that the array has failed, and in that failed state, it is lost. The RAID has no mechanism to come back from a failed array state, right? We may do tricks to try to think it didn't fail, but the RAID itself cannot correct that. There's no means for it to do so. So hopefully that helps you understand where our basis for risk is going to come from and what the terms failed array and degraded array mean, and the idea that we have multiple disk appearances, normally actually disks, that are merged, virtualized together through abstraction and encapsulation and are presented as a single disk or drive appearance onto the operating system, hypervisor, whatever is going to consume that at the next layer up the storage stack. And again, I'll have some references for you below. Thanks for joining me. Remember to like and subscribe. And I hope you enjoyed this series on RAID. And remember to leave comments and let me know what we're missing and what we need to add in to help you make sense of the world of RAID storage.